Okay, so where we are, the lesson we're gonna do today is a redo the solving exponential and logarithmic equations we did before the Christmas break. But I know we don't always remember stuff after a 2-week break, so we're gonna do that lesson again today. Work some different example problems, so you'll have even more in your notes, and then we just have one lesson tomorrow. And then, but we're not gonna test this week, it'll be next week. So what, sir? Next week. Cause we were, y'all, I know y'all forgotten, but we were ready to be finished before the break, but Mr. Withers said, slow down, don't do that, so.
Yeah, cause we're gonna take the test that Tuesday or
Yeah.
something, weren't we?
Yeah, but then we got 3 days instead. I remember because we played Mario Kart.
Okay, so the different types of problems that we're gonna work through, solving logarithmic and exponential equations. I've already picked them out, I got them on my little notepad over here, just a variety of different types. So we can try to remember when to do what. So when there's something like this, what you would notice, or what you need to be able to notice, is that the bases are kind of friendly. Okay, 9 and 3, those numbers jive together pretty good. So if I can create the same base, then if the bases are equal, I could just set the exponents equal to each other. So what I would be thinking here is 3. I could just leave that as 3 to the first, just a 3. But 9 is the same as 3 squared, right? So I can have a 3 for the bases, but the dilemma with this 1/9 is I need to flip it. What kind of exponent flips a fraction? Good, a negative exponent. So I could say here, 3 to the x is equal to 3 to the -2. That gets me 1/9, right? And then I gotta bring down that other stuff that's already up there. Okay, y'all get that? Make a side note over here for you. 3 to the -2 is equal to 1/3 squared, which is 1/9, right? Okay, so now 3 equals 3, check, check. So just set your exponents equal to each other. So we would say x is equal to -2 times x plus 3. And what would you do to start simplifying and solving this?
Distribute.
Distribute that -2, so that gives us x equals -2x minus 6. That kind of got written funny, but minus 6. Now what?
Add your 2.
Add your 2x, try to combine those x's on both sides, so 3x equals -6. Then we're ready for that divide, like Christian said. So x would be -2.
Oh, well.
Alright, so what you're gonna have to be able to do on a test is decide when to do what, because there's lots of different ways for solving these. So our clue on this one were the friendly numbers, 3 and 1/9, 2 and 8, because 8's the same as 2 cubed, right? A 2 with a 16, because 16 is the same as 2 to the 4th. So you're gonna see those that have that relationship that jive together pretty good. All right, I'm gonna leave that problem for next period, so let me just erase my work. Come on.
You should have got some of the people from that period.
Like Bill.
He's in 6th.
Bill should be in here.
All right, let's see what I put down next. Okay, so this one says 9 to the x equals 35. Okay, so if we're checking and trying to decide what to do, we said on the last problem 3 and 9 were friendly. 9 and 35, are those friendly? Do those jive together? 35 is 1 times 5, 1 times 35 or 5 times 7, right? It doesn't jive with that 9 very well. So that's not gonna be an option. So from there, what I'm thinking is b to the e equals n. So that's an exponential form. And when they're in exponential form, we rewrite them into log form. Now, I know it's been a while, but you've got it in your notes, and I'm writing it again. B to the E is equal to N, that's exponential form. Log base B of N is equal to E. So our 9 here would be our B, our X would be our E, and our 35 would be our N, right? So I would write log base 9 of 35 is equal to X. And then you would grab your handy dandy calculator, and you would hit math, and find where it says log base, and fill in those blanks. It's gonna be approximately, what'd you get?
1.62.
1.62. Now, from here you would do a simple common sense check. Okay, 1.62, what two whole numbers is that between? 1 and 2, right? So 9 to the first equals 9, that's too low. 9 squared equals 81, that's too high, so it has to be between them. I think those are probably the easiest ones in my opinion, because your calculator does that for you. Alrighty, but this next one's easy too. Log base 4, 2x plus 8 is equal to log base 4 of 6x minus 12. Any guesses what we might, we've not done one today.
70 position.
Very good. Log base 4 and log base 4, that's the same. So it's just like the first one that we started off with. If the log base and the log base is the same, then the numbers have to be the same. So all we gotta do is write 2x plus 8 is equal to 6x minus 12 and solve this dude. What do you wanna do first? Okay, which one? You'll move the 2 and the 6, so you're gonna subtract 6x, okay? If you didn't start that way, don't change it, you can still get it right. 2x minus 6x will give me and Christian a negative 4x. Now, Christian, for how he started, doesn't have a choice. What does he have to do now?
Move over to 8.
8, very good.
Which is
So we got negative 4x is equal to negative 20. Last step here.
divide by negative.
Add a cube. What did she do? What?
That's a joke.
Don't be doing that. Christmas break was too long for you, sir.
So we spend the entire time daydreaming.
Alright. Is it coming back a little bit?
Kind of sort of almost not hot.
Only. Alright, this one says log base 7 of 3x minus 2 is equal to 2. Alright, and then one yet that looks like this. We don't have a log base 7 and a log base 7 on both sides to set equal to each other, so
we need to set the bin thing.
very good. So we've got one log, so best guess is to rewrite it in exponential form, which would be bin form. So what would our B be? 7 to the what?
Squared.
Equals 3x minus 2. Very good. And now you can figure out 7 squared, that's 49. Now you got a 2-step middle school equation. What should we do?
Add your 2.
Add your 2. So that's 51 is equal to 3x, divide by 3. And we get 17. Nothing to it. Nothing to it.
Well, I thought I was getting back into it until I did 7 squared equals 14.
Oh, that's a brain fart there, dude.
Yeah.
Okay, I got one more on my notepad and then we can still work some more if you need to, but this last one that's on my notepad is what when we do our Wednesday virtual assignment, this is what it's gonna be like.
Is it gonna be one of those like solve the riddle things?
No. Unless I change it. Okay, so what's happening on this one and what you're gonna see later in the week on an assignment is you've got log base 6 and log base 6, like we had earlier, the same logs, but they're not separated by an equal sign this time. They're separated by an addition sign. So when the two or more logs are on the same side of the equal sign, say they're both on the left side of the equal sign, that's going to involve a property. And the properties we learned were product, quotient, and power. So this has got an addition sign. Which property was friends with addition?
Multiplication.
Product, multiplication. So we would condense this down to one log. We would say log base 6 of 3x times x minus 4 is equal to 2. Okay, we condense this down to one log using the product property. So you can go, now it's just like the last problem that we did. You're going to write it in bin form. I'm going to go ahead and distribute here before I do my bin form. Is that okay?
Mm-hmm.
So I'm going to write log base 6 of 3x squared minus 12x is equal to 2. Okay, so now I've got one log, and Christian reminded us to write that in exponential form. So what's my b?
6
6 to the what?
squared.
Second squared equals all that stuff there. Okay. We know 6 squared is 36, but we need to see something weird in this problem.
Take it again.
Put 12.
Did you write 12?
What do we have that's a step up than anything we've done yet today?
Squared.
So we're going to have a quadratic. We solve quadratics either by factoring or quadratic formula most of the time, but we need to set it equal to 0. So we need to go ahead and subtract that 36 over to set it equal to 0. So I'm going to have 3x squared minus 12x minus 36 is equal to 0. Now if you want to go straight to the quadratic formula with those numbers, you can. Y'all are starting to figure me out finally since the year's almost halfway over, and you know that I like smaller numbers. So I realize I can divide all those by 3 and get some smaller numbers. So I'm going to do that. X squared minus 4x minus 12 is equal to 0. Now that's not necessary. You could have had an a of 3, a b of negative 12, and a c of negative 36 and went to the quadratic formula. But since I took the GCF out, I can see now this is easy to factor. Because what multiplies it gets me negative 12, but adds to get me negative 4.
Over no, 6 and negative 2.
Other way though, because my 4's got to be negative. So, but here's what Tyler was thinking. When I set those equal to 0 and solve now, if x minus 6 equals 0, that gets me x equals 6. If x plus 2 equals 0, that gets me x equals negative 2. Now don't circle that yet. This is something I failed you on before Christmas break. When we get two answers like that, remember the big $10 word that starts with an E? That it's a answer you get, but it doesn't work?
I don't know what it is, but I remember.
It was in the song. It was in the Christmas song. Extraneous.
Yeah.
So one of these could be extraneous. So I got to plug both of those back in and see which one is extraneous. And that's going to just, whoops, that's just going to, come on. There we go. That's just, holy cats. That's just, what's
That's a
happening?
new one. Holy cats.
I don't even know what's happening. Anyway, that's just going to, when we plug it back in, that's just going to involve calculator work. So, here, I plug a 6. Okay, so I got log base 6 of 18. Oh, I got room on the side to write this. Log base 6 of 18 plus log base 6 of 6 minus 4 is 2. So you on your calculator now need to type in log base 6 of 18 and add that to log base 6 of 2 and tell me yes or no if it equals 2 or not. log base 6 of 18.
It equals 1.6.
Okay, now add that to log base 6 of 2.
Okay,
Oops, your other graph.
plus,
Yeah, it's the,
yeah, some,
Six or two.
Okay, so we got 2 on that, so 6 does work. But we gotta check our -2 also, so I'm gonna put a -2 in both the x's. 3 times -2 will make that be -6, so log base 6 of -6 plus log base 6, -2 minus 4 is -6. Check that and see yes or no if that equals 2 or not. Mm-hmm.
I get error if I put log base 6.
Yep,
in there.
Yep, so 6 is your only answer. So 2's gotta hit the road, Jack. Don't you come back no more, no more, no more, no more. Alright, let me see here, what do y'all think about that? Was
This
all,
kinda coming back
you
down.
lost me at back there.
well, you could've done the quadratic formula.
Yeah, I don't remember either.
Well, you're gonna have to remember something.
I never remember the song until someone says quadratic formula, and then it pops into my head.
Like that.
Ingrained in there now.
So what we're gonna be looking at tomorrow, our last lesson in this unit, is we're gonna just be given some data, like some points off of a graph. Remember how we talked about what those graphs look like? And from that, we have to be able to write the equations. So that's what we're gonna learn how to do tomorrow. Okey doke?
Alright.
Okay.
The other way around, there's one.
Oh, lost my glasses.